Okay, so I just interesting though that mathematics has a paper two, but the others in the paper two. Well, yes, probably there will be some advantage to that. Okay, so paper three allows us to use a calculator. All right, that's a good one. Okay. But I think we know sometimes using a calculator, there are some questions that, well, you have a chance of being faster um, without a calculator. Okay, all right. So let's see. Um, so I'm starting from the last question, right? That's good with you. Hello, no, are you there?
Yes.
Okay. Okay, so I said that I'm starting with the last question. Is that good with you?
Yes. Yes.
Okay. All right. And it's a good thing we can annotate. So I'll annotate when I need to. Let me just put. Okay, so the last question, 28 says, write 9 times 10 raised to the power 4. Okay, that's a ratio. Ratio 4.5 times 10 raised to the power 6 in the form 1:n, where n is an interesting. Okay, so let's take a look at it. Now, the good thing about a ratio is that we can interpret ratio as division. Okay, we can interpret ratio as division just to make things a bit simpler. So if that's the case, then I have it that I can write this question as 9 times 10 raised to the power 4 divided by 4.5. Sorry, that side doesn't look like a sign. It looks like an X. Okay. 4.5 times 10 raised to power 6. Okay. All right. So that's the first step. Now, the next step is going to be to take care of these guys. Let's see if we can take care of these guys. Now, um, if we wanted to take care of the one that has a decimal point, right? Remember, when you have decimal points in either your numerator or denominator, you need to turn them to a whole number by moving the decimal points of the one that has more decimal places first to the right hand side. And so looking at 9 and 4.5, I think 4.5 has one decimal place, while 9 is actually 9.0. So it doesn't have any decimal place. So I'm going to move this decimal point to where the right hand side, okay? And of course, 9, whose decimal point is behind, will also move one place to the right, okay? And that will be, it will be moving over the 0 there. Okay, so let's see. I know I didn't write the 0, but please just bear with me. There's a 0 right after the decimal point. So it will become 90, okay? Because the decimal point has moved over the 0 to here, okay? But nothing happens to the times 10 raised to the power 4. It's still, um, it's still there, okay? Then on this other side, 4.5 will now become 40 5, okay, times 10 raised to power 6. All right, so let's start taking things out. All right, obviously you can see that 9 can go in here. Let's just use these numbers instead of settling for the small one. Sorry about that. I think I need to erase that. I didn't mean to curve my line there. Okay. All right, so I was saying that 9 will go into 90 10 times, okay, and then 9 will go into 45 5 times. All right, now next thing we're going to do is to say 5 in here one time, 5 in here two times, okay. Now remember we're aiming to have 1 in the numerator. Just have that at the back of your mind. That's what we're trying to do. We want to make sure that we have the value 1 in the numerator. That's on the left hand side of the ratio sign. So for us to make progress on that, we are going to equally um, um, see how we can take care of these two here. Okay. Now for me to take, you know, for 2 to be able to cancel itself, it means that 2 will have to interact with one of the tens in 10 raised to power 6. Now, I know I don't need to say this. I guess you already know it, but I'll just say it for you know saying sake. Okay. If it's only in rare cases that we will need to interact with the number here. And if you are interacting with the number here on the numerator, if you have a multiplication relationship, it will strictly be multiplication. Except if you have a fraction somewhere. Again, let me just say that except if you have a fraction in the numerator. But in this case, they are simple. We don't have a fraction in the numerator. So the 2 would rather interact with one of the 10 in the denominator. So this is what's going to happen. So my next step is going to be 2. I'll just write it out, just take my steps, show my working, which I believe they want to see. And then I now have 1 on this side, right? On the 45 side, I already have 1 because 5 took itself out times 10. Now careful now. Remember, there was 10 raised to power 6 here. So for me to take one of the 10s out so that 2 can go into it, I'll now be left with 1 times 10 times 10 raised to power 5. Okay. Please confirm that you understand what I just did.
Yes, yes.
Okay, good. So you know what I'm going to do next, right? 2 will go in itself 1. I've achieved part of my goal. And 2 will go in 10, 5. Okay. Then remember you still have 10 raised to power 5 on this side, right? And you have 10 raised to power 4. There are 2 things you can do. You can see that it seems like you have an extra 10 on this side. So you can say don't know how you want to say, but you can do this 10 raised to power 4 into itself one time, and, and then 10 raised to power 4 into 10 raised to power 5, you'll be left with 10. Okay, that extra 10 that needed 10 raised to power 5. Okay, now in your numerator now you now have 1 times 1, which is what? 1. That's what you wanted to achieve. And in your denominator you have 5 times 10, which is what? 50. Okay. Now, did you get what I just did back there?
Yes, 1 to 5.
You too? Okay. All right. So that's going to be your final answer. Do you, are you good with that?
Yes.
Okay, awesome. All right, so let's go to the next question. The next question is talking about um, order of size. Okay, starting with the smallest number. All right, so quite tricky, but I'm sure it's something that we can handle. So out of these numbers, right, which one seems to be the smallest? Now, let's be to be on the safe side. We are going. It's best for us to change all of them to numbers without the 10. If you can avoid the 10, or I don't know which one you feel is simpler. Okay, you know what? To be fair, let's change all of them to numbers without times 10 raised to power 4. In other words, let's change them to their non-standard form. Okay. So for this guy, let's start with this one, the first one, 5.625 times 10 raised to power 4. 5 point, I think I should use a dictate for that. I should use a text box for that to make me faster. Okay. So here we go. All right. So this is what I don't like about the text box. It, it seems to, okay, I think I'm fine with this now. 5.625 times, no, I got stuck. Okay, there we go. I have to go back to that because of the power. Okay, I'm stuck with this guy. All right. So 5.625, I just realized that I have to put the power back there, right? Times 10 raised to power 4. Okay. So let me erase that because, yeah. So, okay. So I needed to give some space to do what I want to do. Times 10 raised to power 4. Okay. So let's implement it. Now, times 10 raised to power 4 means what? The decimal point is going to move 4 places. Please take note. Anytime the power on 4 on 10 is positive, we will move in the right hand side direction. So we have 1, 2, 3, and what? 4. Okay? And 4. Sorry about that. So because there's no number after 5, I'm going to put a 0 there. So this number that you are seeing here is actually 5, 6, 2, 5, and 0. Okay. Next, this guy is already in non-standard form. So just bring this down. It's already in non-standard form. So it's just 5, 6, 2, 5. Next, we have our guy here. Times 10 raised to power minus 3. Now, because I think I seem to have some luxury of space here. So times 10 raised to power minus 3 is going to take this, because it's minus 3, it's going to move to the left hand side 3 times. Now, I know somebody may look at this and think, oh, there's no decimal point. But please don't forget, every whole number has its decimal point after the last digit on the right hand side. Okay, so even if you can't see, the decimal point is right there after that 0 there. So we're going to move 3 places to the left, and that's 1, 2, and 3. Okay, so here we go. The number will now become 56. I think I think this method is a good method when you can see the numbers really for themselves, what they are, without the standard form. Now, finally, we have 0.005625 times 10 raised to the power 5. And because it's a positive, we are moving towards, sorry, let me put a direction on this guy. This one was towards the left. This one was what? Towards the right. Yeah. and this one is also going to be towards the right. So don't forget that. After I'm putting that arrow. So then I now use the arrow and shorten my guy. So I'm going to put the arrow under just for you know for me to have some space at the top. So here we go. Times 10 raised to the power of 5. So we're going to go 1, 2, 3, 4, and 5. And that's going to be right between the 2 and the 5. So these zeros in front, you can throw them away. You've achieved your aim. Okay, so they've done their job. So you can just go ahead and write your 5, 6, 2, and don't forget the point that landed there, point 5. Take note that once you deal with the 10, once you interpret the standard forms, you don't need to write them again. Here we go. So can you tell me which one is smallest by your own judgment? Which one is the smallest?
The third one.
Which one?
The third one.
This one, right? Okay, yes, the
Yeah.
third one, yes. Okay, so followed by, so this is, okay, let me just write it. Now I know what you're thinking is, should you write the standard form or should you write this one? Well, since they said write the following numbers in order of size, I think it's fair for us to revisit the one that they gave us. So let's just write it according to how the question came. So sorry, 5, 5, 6, 2, 5, 0 times 10. Okay, raised to power minus 2. Okay, that's the first one. Then what's the second one?
The last one.
The last one, correct. That guy looks like a handful. 0, 0, 5, 6, 5 times 10 raised to power 5. Okay, next, the second one, right?
Oh, yes.
2, 5, and finally, the first one would count as largest 5.6 to 5 times 10 raised to power. Okay, okay. I guess we're good with this. So we can proceed. Okay. Solid keyboard is made of metal. The metal has a density of 9 grams per 9 grams per cubic centimeter. Um, the volume of the keyboard is 72 cubic centimeters. Work out the mass of the keyboard. All right. So if you remember the formula for density, density is given by mass per unit volume. And this is what I always tell people. If you look at the units of a quantity, especially a mathematical of a mathematical quantity or a physics quantity or even chemistry, most of them are just related somehow. If you look at the unit can give itself away. So take a look at this side, grams per cm cubed. Okay, that slash there is read as per. We read it as per unit, cubic centimeter. But usually it's just per that people read it as. And that slash there can, suffice as division. So once you see, okay, so what quantity is grams representing? That's mass. That's the guy on top. Okay, that's the gram. And then what quantity is um cm cubed representing? And that's volume, okay, of cubic centimeter. That's volume. So you already have, even if you forgot the formula for density, the unit can remind you. Okay, so just have that at the back of your mind. Density is equal to mass over volume, or mass per unit volume. Okay, so let's go back to the question. They told us that the metal has a density of 9 grams per cubic centimeter. So I'm just going to place things where they belong. So the density is outside there, 9. That's the subject of the formula. 9 equals mass, we don't know. So we're going to represent mass by letter M. Just leave it like that. And then the volume we know at what, 72 cubic centimeters. Now let me just say something here. Sometimes the question may be tricky and they will not put the right unit. What do I mean by that? For instance, you know that cubic centimeter, there's cubic meters too. There's cubic decimeter. There are so different classes of cubic. So please take note that if the volumes, what do you call it, unit, right, doesn't match with what you see in density, then you need to do a conversion, okay, to match with the density. All right. So take note of that. But for this, they match. So you have cm cube, grams per cm cube, and you have cm cube also. And of course, nobody needs to tell you that the unit of mass will eventually be grams, okay, because that's what matches with the unit of density. All right, so let's flow. Now, the next thing that we need to do is to make M the subject of the formula. And how do you do that? Okay, so let me see if you can help me out here. So what am I going to do to make M the subject of the formula here?
9 multiplied by 72.
9 multiplied by 72. In other words, multiply both sides by 72. Okay, that's another way of saying it. Okay, so that's what I'm going to do now. So when I multiply here by 72, I'm sure you can tell what will happen. 72 will take itself out by 72 on the right hand side. But it's going to also happen to the left hand side for us to have a balanced position. Okay, so we have 72 times 9. Okay, so 9 times 2 we know is 18. So these are the kind of calculations that a calculator can actually slow you down. Because by the time you are punching and you are too fast, you could miss out things. 9 times 7 is 63 plus 1 is 4. But again, if you are not really confident about your times table, that you learned by rote, okay, please feel free to use your calculator. If you are not confident about your times table, or if you are, and I usually try to tell all my students, always have your timetable, like have your A game when it comes to your timetable. Okay, so you will not be stranded at any point. Then you can go ahead. Okay, so that's the answer. That's the math of the cuboid. So you can just write it in 648. No need, since the unit has been written, you can just leave it at that. Okay, so did you get the concept of this question?
Yes.
Okay. All right, so we're moving on. Quadratic equation. So they told us that this is the graph of y equals x squared, yeah, minus 2x minus 2. Okay, nice looking graph. Okay, what does it say? Write down the coordinates of the turning point on the on the graph. Okay, so the turning point is simply where the graph turns, and there's no other turning point than this. I'm going to put a circle around it. Okay, first I'm going to mark it. Okay, so that it's easy to read, and then I'll now any need to put a circle, no need. Okay, so just place it to the y-axis, and of course, let me make it bolder so we know what we're talking about. Then place it to the x-axis. Anyway, we all know that x comes first, the first of order. So this is another place people are going to miss it. If you go and put the y value first, you're going to be wrong. So the x value is 1. Sorry for writing my 1 like that. And then minus 3. So that's the turning point, the point at which the graph turns. Okay, write down an estimate for one of the roots. They don't really need us to find two of them, but instead you should write down the estimate for one of them. So if you tell them one of the roots, maybe the one on the left hand side, you will still be correct. If you tell them the one on the right hand side, you will still be correct. So for our own exercise, I'll just do both of them. So now they said an estimate. And the reason why they're saying an estimate is because the graph interestingly cuts the squares in a quite odd position. Okay, so we can't even say that they cut the squares in the middle. So let's see if we can get the roots. Now remember, the roots are where the graph cuts the x-axis. Please always remember that fact. So in this case, the first root is here, where you can see my pencil. Okay, so let me just put a mark in there so that we will now try to decipher um what point is that. Okay, then I'll put okay, no, let's just put a marking on this second one, and we'll come for it. Okay, all right. So here we go. For that one, let's interpret the scale. The scale looks like it's 1 cm to 1 unit. Okay, and 1 cm to 1 unit means each of those individual squares will be 0.2, because it's only 0.2 that you multiply by 5 to give you one whole number. Okay, so let's read it this way. So this is going to be, the left hand side is going to be minus approximately, please. Remember, it's an approximate, minus 0. This is 0.2, 0.4, 0.6. Okay, so it's closer to 0.8 than 0.6. So in between 0.6 and 0.8, I guess it's safe to say that we have 0.7, isn't it? So yeah, I think you can say for that left hand side, we have minus 0.7. That's the closest estimate I get. Now, if you want to, estimate it up to a whole number, right, you can say minus 1. But I think, when it comes to estimates like this, I think it's safer to, um, you know, maybe it's good to just put an or, because they didn't say the estimate has to be a whole number, not compulsory. But yeah, so that's it, minus 0.7. So let me just put the word approximately, approximately, okay, so that we know that these values are not exactly. So I'm just going to put approx as, short. Okay, now on the right hand side, you do the same thing. Then it's going to be 2.2, 2.4, 2.6, and approximately 2.8 again. And I think we can stick with 2.8 for this one. Okay, 2.8 or 1 or 3. Okay, all right. So did you get that? I don't know why you there.
Yes. Yes.
Okay, all right, good. Okay, all right.
Yes.
Uh-huh. All right, so let's go on. The next one says lava flows from a volcano at a constant rate of 11.9. Oh, okay, that is a unit I'm practicing for the first time. Meters cubed or cubic meters per second. Okay, that's understandable since lava is a liquid and it flows as per volume. Okay, it's understandable. So that's the rate at which it flows per second. Okay, that means every second it throws out 11.9 cubic meters of lava every second. That's the interpretation of that unit, of that rate. Next, it says how many days does it take for, oh my goodness, 67,205,600 cubic meters of lava to flow from the volcano. Okay, it says give your answer correct to the nearest date. All right, that's fine. Let's see. So if we understand, remember how I think I got a hint of this question because um the unit looks like it gave itself away. 11.9 cubic meters every second. So for us to find out how many seconds are involved, what do you think we're going to do, Noah? What do you think we will do?
In 4.
What did you say?
Sorry, yeah, divided.
Say add.
The divide
Okay, divide. Okay, divide what by what?
the 6,000. Divide the big one by the smaller.
Okay, bigger one by the smaller one. Okay, so that's actually 67 million. Okay, so you know what? Could you help us with your calculator? The number is pretty huge, so let's not, no need to attempt to do it without the calculator this time. So we're going to divide, just like you said, the big number, 7 million, 205,000 by 11.9. Okay, so when you do that, what did you get?
5647.
Okay, hold on. 5647,
529.
5647, 529, you said.
Yes.
Okay, excellent. Now, this value that you just got is the number of seconds, okay? Because that's the number of times we can find 11.9 in this large number, okay? I remember 11.9 is spilled out from that volcano every second, okay? Per second. It's spewed out from the volcano per second, okay? So now that means we have found out how many seconds the volcano probably lasted, okay? Now, the question is this: how many days will this amount to? So we're going to find out how many seconds are in a day. Okay, so do you have that value offhand or do you want us to calculate it? If we have to calculate it, we're going to say 24 times 60, that's 24 hours times 60 minutes And since each minute has 60 seconds, we're going to multiply everything by 60 seconds. Okay, so I'm going to multiply everything by 60 seconds. And what will this give us, please? 1,440. I just wanted to confirm. What will
Wait,
this value give us?
why are you
Yeah?
multiplying the two as well?
Yes, yes, 24 times 60 times 60. We want to find out how many seconds there are in a day.
Yes, so is it not 60 times 60?
Yes, please.
No, I'm asking, is it not just 60 times 60? And then you divide it by
No,
24 after?
no. 60 times 60 will give us how many seconds there are in 1 hour. But now we need how many seconds there are in a day. So we have to multiply it by 24. Did you get that?
86,400.
86,000,
400.
86. Did you say 400?
Yes.
Okay, awesome. Okay, thank you. So this is the number of seconds in a day. Now we now have something we can work with. You know what we're going to do next? Because the question says give your answer correct to the nearest day. We're going to divide this by day to find out how many days are involved. Okay, so are you ready to crunch that number for us? 5647529. Okay, 5647529 divided by 86,400. Okay, so what would this give you?
65.
Is it approximately 65 or it's exactly 65?
Oh no, approximately.
Approximately. Okay, so I wanted to put the actual value then approximately, but since you gave me approximately, I think I should just use that sign there to make it look like approximation. You said it's 65, right? So I'll just take it as base value. 65 days. Okay, so did you get the breakdown of the calculation?
Yes, yes.
Okay, don't worry, I'll send this to you as soon as we're done. I'll save it. Okay, so next on the lineup of questions, we have this is like another standard form question, and it says A and B are numbers such that other stuff within them. It now says find the highest common factor of A and B, and then second one says find the lowest common multiple of A and B. Now, there are two things you may decide to do at this point, but I'm not sure you want to do the second one. So the first one is to solve this question with the numbers exactly the way they are. The second one is to change them to their non-standard form. Okay, but then I promise you that that second one you don't want to do it. It's going to be probably more complex and more problematic for you. So I think the first one would be to just use the numbers in their standard form the way they are. So it says find the highest common factor, right, of A and B. Now let me just ask, if you were to do this using these numbers as standard form, how would you find the highest common factor of A and B? How would you do that? Remember, the meaning of the highest common factor of two numbers is simply what the factor that they have in common. Okay, so probably they have several factors in common, right? That will divide into them without remainder. But then we're talking about the highest that they have in common. That's simply what the highest common factor means. Then of course the flip side, lowest common multiple is the biggest, the smallest multiple that they have in common. Okay. So let me hear from you. How would you do this question? How would you take on this question? No, are you there?
Yes.
Okay. So how would you take on this question?
Is it 3 to the power of 5 times 7 squared?
Okay. Three squared. Did you say three squared times 7 or 3 squared times 7 squared? Which one?
Pardon?
Well, I didn't hear what you said. I didn't get you back there.
3 squared times 7.
3 squared times 7. Okay. So I'm guessing you took the 3 squared because they have three in common, and then you chose the lowest power, which is squared. Yes. Okay. And then you looked at 7, and you chose 7 because 7 was the lowest on the other guy's side. Okay. 2 doesn't come into the picture. Yes. So um well, now that they say fine, I don't know. You then okay. So I don't know how you show you're working, but anyway, um, okay. So I don't know. Let me see if I can show some form of working here. Right. So we have 2 squared times 3 raised to the power 4. Okay, and times 7. Okay, and then you have b, and then equal 3 squared, okay, times 7 squared. Okay, so yes, 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 yes. So, uh, so yes, if you interpret the squared, then 3 squared will be the lowest for this guy, and then for the 7, this one would be um, the lowest. So that's what they would have, their highest common factor. Okay, so yes, I think I don't know if you are comfortable showing you're working like this, but this is how I think I would have done mine. Okay, um, because they are talking about the factor, and factors, uh, in this case, what would be able to divide into both numbers without a remainder. Okay, so let's now go for the multiple, the lowest common multiple. Okay, so what do you think will be the lowest common multiple for this one?
Um, 2 squared
Okay.
multiplied
Yeah.
by 7.
2 square. Okay. Okay. Multiplied by. That. So in this case now we're looking for the biggest ones, right?
Oh,
Two
yes.
squared multiplied by this and then multiplied by this. 7 squared, right?
Yes.
Okay. Okay. No, okay, I agree with that. Okay. Okay. All right. That's fine. So we move on. Okay. So 23 says it takes 14 hours for 5 identical pumps to fill a water tank. It says how many hours will it take 4 of these pumps to fill another water tank of the same size? Okay. So questions like this are proportion questions. Um um the first thing you would ask yourself is if it took 5 identical pumps 14 hours, right, to fill a water tank of this. And another, then how long will it take? Will it take 4 of those same pumps, um, um, longer period or a shorter period? Now, if, imagine that these pumps were likened to humans, right? And you reduce the number of people doing a particular job, then obviously, if they are working at the same rate, it will take 4 people a longer time to do what 5 people would have done. So if we apply that same um, concept in this case, then I think that's what will happen. It's going to take those four pumps to, a longer time. So now this is how I'll go about it. Or do you have a method you use to solve questions like this? Do you have a method that you use to solve questions like this?
Um,
Do you?
I usually multiply the hours by the,
Oh, you just multiply the hours.
yeah, 14 multiplied by 5.
Oh, really? Okay. Okay. So, well, this is how I go about mine. So 5 pumps will do 14 hours. 4 pumps will do X hours, right? So, let's see. 5 pumps will do 14 hours. 4 pumps will do 8 hours. So, and now I've established that the number of hours will be more. So that's a case of inverse proportion. Okay, and since it's inverse, um, I would do like a cross kind of thing. So that's going to be 5/4 equals um, x over 14. So this is how I usually handle mine. Just, I don't know. This was one of those topics that I had to just find a way to get around it. Okay, so yeah, so you know, to do your cross multiply or just like we did for the other one, multiply both sides by 14 to find what x would be. So you go that therefore x would be equal to 5/4 times 14/1. Okay, so Noah, can you handle this for us? or maybe I should just do 2 in 4 is 2, but I think this may not give us a whole number, so um, 2 in here is 7, we have 5 times 7, 35, 35 over 2, and 2 in 35 is 17, so that's 17.5 hours, or 17.5 hours, anyone you wish. Okay. And now, usually it's safe to ask yourself, does your answer match logic? Now, if you check it, 17.5 hours is actually more than 14 hours. So it agrees with our expectation, which is the fact that 4 pumps will take a longer time. I usually do that check. Okay. All right. So have a good night.
Thank you.